All right, so hi everybody. My name is Gerd Zellweger. I'm a co-founder at Feldera, and today's webinar is going to be about incremental spreadsheets with Feldera SQL. But really, we'll see it's about a bunch of other things too. So I'm excited to be here and show you. Okay, so let's get started. So first of all, spreadsheets, right? So we should be all familiar with spreadsheets. By the way, interrupt me at any time. If you have any questions, you can just raise your hand in the Zoom. Lori will unmute you and then will let me know. So that's totally okay. So spreadsheets. So here's a spreadsheet that we built. That's not like Excel or Google Sheets, but we built it with Feldera. And there's kind of two reasons why we did this. So first of all, we often get asked in our Slack channel, well, can I build like a real-time live web application that immediately responds to changes and sends those updates to everybody, etc., etc. And turns out, yes, you can. Feldera is a really nice way of building kind of these web applications that are reactive and that immediately always display the latest state. And so the spreadsheet is kind of like one way to exemplify this. And the other kind of way thing of doing it is, well, what a spreadsheet needs to do, right? So obviously it needs to be able to put values into cells, and it needs to be able to kind of like reference other values by writing these formulas, and needs to be able to kind of do calculations using references, etc., to compute values. And these kind of things are also something that is actually something we can do very elegantly with Feldera, as we'll see in the webinar today. And finally, right, so you can see here in the title, this kind of spreadsheet, it has over 1 billion of cells. You can do those, update those cells easily. So cool. So, okay, getting back to it. Yeah, so we can obviously put these values into cells and we can compute kind of cells. But another thing we really want to do is when we have like such a huge, massive scale of data, right, is that we make sure that when one of the cells changes, right, we don't want to recompute all the other cells. We just want to really recompute the cells that are affected, like this one and this one in this case. And we don't only want to propagate those changes, the things that changed, like the minimal amount of cells that changed to the clients, right? And then, hopefully in the rest of the webinar, you'll also get a glimpse of, how this is done very easily with the Feldera incremental model. And finally, like the last part is, when you have a spreadsheet like this, you only kind of look at the very small view of the actual cells, if you have over 1 billion cells here. So you really want to only propagate changes within that range to the clients, right? To make very efficient spreadsheets. And then this is also something that is very easy to do with Feldera, that we may not see exactly how it's done, but we kind of like wrote a bunch of accompanying articles with this that we'll share at the end of the talk as well, where you can, if you're interested in building a similar application, or you have a similar use case, you can take it as an example. Okay, so with that, let's go jump back to my slides. A second. Okay. Presentation mode. Okay, so what we'll do today is obviously we'll write kind of like this example I just showed you. It kind of has 3 parts. So there is a Feldera pipeline running at the top. There is a REST API server in the middle, and then there is the browser client at the bottom here that accesses it, that you see. We'll mostly focus here on the top part today, on that Feldera pipeline. So this one here. And we'll basically write the code that powers this thing that we just saw as an example. And part of this exercise is to help you understand incremental computation and how it works with changes and how it makes these things very efficient. And then especially the part I mentioned, where we automatically recompute only the minimal updates for a spreadsheet whenever a cell changes. And the nice thing is in this application, we actually also get to use some more advanced feature of Feldera, like user-defined functions, UDFs, which are things where you can like break out of SQL, write something in Rust in this case, and invoke it directly from the SQL code, which makes it more powerful. Where sometimes you cannot express things in SQL, and you can use Rust for these things. And the second thing we're going to see, which is also kind of an advanced feature, which is recursion, which actually recursion, I'm very happy with the recursion that we did in SQL, because it's a very nice way of doing recursion in SQL, if you're familiar with other ways. And so we're going to see how we can like very easily at the end, just by changing a few lines of code, make our program a recursive program and actually, compute kind of like powerful chaining of references by looking them up through whole chains, etc. Okay, so let's get started. So first of all, let me try to move one slide forward. Let me try to kind of like talk a little bit about the problem we're trying to solve today together in this webinar. So first of all, what I earlier did, right, when I opened up the spreadsheet is like I entered those 4 cells, right? So I'll fill them with value. I put 41 here, I put 1 here, I put B0 here, and I put this other formula A0 plus C0, which evaluates to, through this kind of chain reference here, 41 plus 1 gives 42, right? So we're going to try to, build a spreadsheet that can do this. And this is sort of the heart of every spreadsheet. So once a spreadsheet can do this, you can do most of the things that you need to do in a spreadsheet. And, obviously, in order to kind of do this, so this part here is easy, right? You just need to compute 41 here because you already have 41. This part here is easy too. You just can compute 1. If you want to evaluate this. This part here is slightly tricky because, now you have kind of you need to figure out that you have a reference here and that this reference really points to this value here. And, once you follow that reference and can look up this value for it, you know that you need to put a 1 here if you were to build this. And then in this part here, it's slightly more tricky because now first you have the same case as we just saw where you have a reference that just goes here. So you can put 41 here once you realize that this is a reference. And then in this case here, you have a slightly more complicated case where the first reference points to the C0, which isn't really a value yet. It's just another reference, right? So we need to find this reference and then find this one again. So we kind of need to do this chained lookup in order to find this value 1 here. And so once we do that, we need to evaluate 41 plus 1. And so then we can say, yes, this is 42, right? So this is essentially the problem of our spreadsheet that we're trying to model in Feldera. And of course, all the other parts which Feldera implicitly does is, if you go and, you change this value to say 0, then, it will kind of like do the minimal update of changing this one to 0 and changing this one to 1, but, not doing any changes for the values here and here. Right? Okay, so as I said, the rest of the talk is really just about building the core logic that does this. All right, I'm going to erase this again. Okay, so the first thing we need, right, is we need to be able to essentially store the part here, the top part here, where we have these raw values that we enter as a user. And what we're going to do for this is we're just going to put them in one table, right? And it's a very simple table. We just have 3 fields. One is the ID of the cell, which corresponds to these things up here, A0, B0, C0, D0. And then we have a timestamp, meaning when we entered the value. We'll see why this is kind of interesting in a little bit. And then the last field is the raw value, which is the values the user actually enters here, the formulas and the 41 and the 1. So let's try this for a second. So if you want to try this yourself, we sent you instructions on how to install Feldera using Docker or using from source in an email, but you can also take this command here and run it. I'll paste it for you in the Slack channel or in the Zoom chat. I mean, sorry about that. And once we do that, we should be able to get Feldera up and running, right? So you should have a view like this if you go to localhost 8080, and you should see our Feldera platform. So So the first thing we're going to do is we're going to create a new pipeline here. We call it XLS. You can call it anything you want. And we should bring up the program for us. So now we're going to enter some code into the program. The code I'm going to use today in the webinar, I put it in a GitHub gist. I'll send you the gist as well in the chat, or Lori sent it to you, which is very nice. Thank you, Lori. And so if you look at this gist, there's actually 3 files here. And for now, we're just going to take all the code, paste it in. Don't worry about it. We're going to look very detailed at the code in the next 30 minutes or so. But I'm going to just follow the steps, and you can complete the steps too on your own if you want, or you don't really have to. You can also just watch me do it. So I'm going to take the first file. I'm going to program it. This is just a SQL part. We see actually the table we just showed with the 3 fields is the first thing we see here. So we're going to put this in program SQL. And then I'm going to take also the second file, which is a udf.rs file, which is the Rust code that contains our user-defined functions that we're going to invoke. So I'm going to paste this into our code too. And then there is a third file, which is UDF.toml, which is a bunch of metadata for the Rust code of which libraries we're going to import into it. And so we're going to copy this into the last tab in our web console here, udf.toml. All right. So if you do all of that, if you copy and paste all those code examples, what you will see is the program will start compiling. It might take a minute or 2 until it's compiled, but afterwards we should have a program we can run. So I'll let it compile here for a second. I'm going to switch back to my slides. And so going back to our table, so the first thing we're going to do is we're going to enter some data into the table. And it's going to be the same data that we have entered all this that we've looked at when we did the spreadsheet and that I showed you before. So it's going to be 4 rows only. We're only going to work with these 4 rows and sometimes occasionally insert one more to show how things works. But basically, we have these values and 2 formulas, and we're going to have cell IDs here. And there is kind of like 2 kind of coordinates that we have. One is the cell IDs that we use in the spreadsheet data table, which is from 0, 1, 2, 3. And these correspond to kind of like cell references in Excel or in that you're familiar with in spreadsheet, which is usually you have a letter for the column and then you have a number for the row. So A0 here corresponds to ID 0, B0 to 1, C0 to 2, etc. So you can just assume this mapping is given. The only time we need to kind of transform between those 2 IDs is when we invoke Rust code, user-defined functions. But we actually, if you look at the user-defined function code in more detail, you'll see that we have functions that do this conversion, right, that do this for us. So that's something that is easily taken care of. And then we have the timestamp values here. Okay, so starting with that, going back to our spreadsheet for a second. So here, you'll also see that I added some kind of metadata to this table down here. Now, this isn't, it's a bunch of text, but really what it does is it just makes sure whenever we start up our pipeline, we insert these 4 rows that I just showed you by giving the values here for the ID column, giving the values for the raw value column, and giving the values for the timestamps that I just inserted. So we can try to start our pipeline. We're going to select in the change stream, we're going to look at what happens to the spreadsheet data table. And if we start it up, we should see that indeed those 4 rows were just inserted by having written this data gen configuration. We could have also written ad hoc queries and inserted them with insert statements, but this is kind of convenient because every time we start it up, it will actually automatically put the values in for us. Okay, so now that we kind of have a table and the table has the data that we entered as a user, we need to now go and compute actual values for these, especially for these B0 and A0, C0 cells, right? And so for that, I'm going to switch back to my slides. And we're going to, in Feldera, right, what you do is now you kind of iteratively write views on your table to transform your data into different shapes, right? And so our goal is to kind of like, at the end of the day, have a way to get to this computed value here, right? So for every cell, for every ID, we want to have another field where we store not just the value that the user entered, but also the value that we compute as Feldera. Okay, so this is the first view. So this does 2 things. So first of all, we'll see that there is kind of like a subquery here within this view, which is called max timestamp per cell. And what it does is just for every kind of cell that we have stored in our table, it will pick the latest entry with the maximum timestamp, right? So for every cell ID, because cell ID is not actually a primary key. If you look at our table definition here, you can just put any amount of values for any ID set for any ID. And so if you want to like override a value, you would just update the cell with the new timestamp. And so here what we're doing is we're just selecting the last value that we inserted into spreadsheet data by picking the one with the latest timestamp. And this kind of query selects the max timestamp, and then later here we actually find it by looking it up by doing the join on the original spreadsheet data table. So that's the first thing we do. And the second thing we do is we have a Rust function called mentions here. And it's a user-defined function that is calling into Rust code that we declare here. And we call this mentions function here on our raw value. And we can see that it takes a string, right, which is our raw value here that we entered into the cell, and it returns an array of integers, right? So what mentions really does is it tries to parse the references from the formulas and give us an array of references, meaning cell IDs, really, and return this as an array. And so this is something we can conveniently express in Rust, right? Because it would be probably hard to kind of parse arbitrary Excel formulas in SQL, so we can use Rust to do that for us very easily. All right. So just to kind of exemplify what happens here, if you look at our tables again, so this is the original spreadsheet data table that we just saw in the earlier. Then this basically computes this max timestamp per cell, where here we just have one entry for each cell. So we just get all the timestamps, which are the max implicitly. And then this view, the final view, latest cells that gets computed, now has a new column mentions. And mentions always has a null in it because we actually added it. That's going to be important later when we do an unnest operator, just so it picks all the values, even though they don't have any references. But you can ignore this for the remainder of this talk. And for the formulas that have references, right? So here it adds a 1 to it because it has B1 here, and 1 is actually the ID that B1 points to. And then in this case, it adds 2 values into our mentions array, 0 and 2, because A0 and C2 both point to ID2 and to ID0. Okay, so let's see this in action for a second as well. I'm going to stop the slides. I'm going to go back. So we see that we added the same kind of view here that I just showed you, that I just explained. And we have this UDF, user-defined function mentions, and we can look at this UDF here just briefly. What it does, it really, gives us back these arrays. It's written in Rust. One of the nice things is that once we allow Rust code, we can also include other Rust libraries that people have written. So actually, I'm not really doing much here. I'm just invoking a library that somebody else wrote, which is called Excel Formula Engine. And it's publicly available under an open source license. And it does all this complexity of looking at the formula, an Excel formula, and trying to find references and give me references as integers back. So roughly, I'm not going to go through it, but if you want to study this in detail, you can do that. Okay, so just for a second, let's start it up and look at it. We're going to enable the change stream for our kind of latest cell changes here and for this view. And what we'll see is that, we'll get this thing that I just showed you in PowerPoint, right, where we have this new column here, which is an array of all the references as integers to other cells that this raw value mentions. So that's great. Another thing I can show you here is that we can actually, modify an existing cell by just inserting a new value for it into our spreadsheet data table. And we're going to use a new timestamp here, right? So we're going to say this is from today, and we're going to see what happens to the latest cell value, to the latest cell view. So if I execute this statement here, what you see is there's Feldera computed two changes that it needs to do in the latest cell view. First, it needs to delete the row 0, which is 41 here as a raw value. And then it needs to insert a new row for 0, which has a value of 99. And the reason it did that is because we have our max timestamp per cell clause, right? So we added a new value to spreadsheet data with a newer timestamp. So because we say we only want the values here with the latest timestamp, it did those two changes to this view for us, and it emitted those changes to us. And that's actually a very nice way. So for example, if you wanted to build an undo mechanism in your spreadsheet, right, you could just always go back. It would just be deleting the latest, the row with the latest timestamp, and Feldera would give you the minimal necessary changes how to update your spreadsheet, which cells are affected by this deletion. Same thing if you insert something, right? Feldera computes the minimal updates that you need to do, which cells you need to change, and sends you this as changes. All right, cool. So moving on, we're gonna now, we basically have this thing where we computed all the IDs for it. And what we'd like to find is for those IDs that we reference, we don't just want the ID, right? We want the actual value that this thing references. So we're going to do two kind of additional steps. So the first one is we're going to write a new view, which takes this array that we had before, and it calls unnest on it. And what this does is it just it takes these arrays or values that were in there, and it kind of duplicates the row, and for every element in the array. So as we'll see, out of this array with null and one entries, we have now instead a table with two rows and one with the null and with the one as entries here in our mentioned ID column. And for this one, where the array had 3 entries, right, we now have 3 rows with null, 0, 2, where each of those are an individual entry in our table, or in this latest cell with mentions view, rather. So this is nice because the good thing about this is now we can actually use SQL again, right, to take this column, the IDs that are in this column here, and join them with something, right, with some table or some view to get the actual value that these things represent, 1, 0, and 2 here. And so we're going to do this in the next part, right, where we write another view. Right? So in Feldera, you often write views on top of views on top of views, and that's perfectly fine thing to do. It's very efficient. It might not be, you might not be used to this because in many database systems, it's not as efficient to do it, but here, this is perfectly okay. So the next view, we call it mentions with values, is where we do exactly that. So we take our ID, raw value, and dimensioned ID, and we get a new column here, which we take the raw value again, but we now do a join to get this, where we join it on the original table spreadsheet data, and we use the ID that we had here, and we join it with the cells that were in this spreadsheet data table. So how does this look like? Well, okay, it's easy, right? So it just adds this new column here. It's exactly the same table as before with this column added. And for each of these values in this column, we looked up. So if we had B0 here, this translated to this ID1 here. So the join it did was it looked at the ID here and it took the value from this one here and put it here. Right. Similar here, 0, it looked up the value 0 and it took the raw value 42 and put it here. And for 2 here, again, it did the same thing. It took the value 2 and it looked up the raw value here for it and it put it in this column here, which ended up being B0. Okay, so with that, now we have kind of like, we're almost there, right? So we basically have for each of our cells, we have what kind of IDs are mentioned, and we also have the corresponding values that we mentioned for it. The only annoying part is now we have kind of like too many rows, right, for each of the cells. So we have 3 rows here. We really only want like one row per cell. So we kind of need to flatten it again and make these things arrays again. And that's something we can kind of easily do using in this array aggregate function in SQL, where we just, and the group by on the ID. And so what this does is just, aggregates these 3 values and these 3 values into an array, and it aggregates these values and these values into an array and makes everything in these 2 columns arrays. So if you do this, here's what it looks like. So now you have kind of like arrays here for everything. And then you just, the key part is we only have like 1 row for each cell ID again, right? But we have the whole context, right? If we want to evaluate the formulas, we can look up values for it by looking into mentions values arrays. Okay. So the last part is just evaluating the formulas. And for that, we cannot do it in SQL easily because, this is like arbitrary string parsing again, and, recognizing that something is a formula and something is a reference, etc. So this is, again, a great use case for a user-defined function in Rust. And so we're going to declare, again, another user-defined function here. And this user-defined function takes that, that the formula itself as the first argument, the array of mentioned cell IDs and the corresponding cell values as another array, and it returns us a string, which is the computed value. Right? And so we're gonna go switch back to our software here again to see what happens. So let's just go down and look at this view again that we see here, the latest view. Which is called spreadsheet view. And we see this is exactly what I showed you in the slide. And we can also quickly look at the UDF or this user-defined function here, which is in Rust, right? Which we will find over here in this tab. And we'll see that it doesn't do much. Again, it's a bunch of Rust code that just, takes this context of, all the values that we mentioned and the formula itself, and it will spit out a new string, which contains the calculated formula, the calculated value of it. Again, not going into too much detail here. If you want to study it, you can on your own. Okay, so let's see. Let's run this. Right, so I'm going to enable kind of this spreadsheet view here, which should spit out the values that we wanted. And I need to shut this down and start it again. And we look at the changelog, and we see that it did actually compute something, right? So we have a new column here, computed value, which is really what we worked so hard for, right? What we wanted to get to, where we can evaluate those formulas. And so for 41, it worked. It was easy, right? For 1, it worked. For B0, it worked. And for A0 plus C0, we see that it actually returned hashtag value exclamation mark here, which, if you're familiar with Excel, it usually tells you that something went wrong in how it evaluated the value. So what did go wrong? Right? And so let's look at it for a second. So what happened, right, originally is that when we calculate this formula A0 plus C0, we had this mentions with values view that we computed originally. And we saw that for this last kind of row entry here, it figured out that C0 mentions row number 2. And that row number 2 really has a raw value that we took here of B0, right? But then we propagated this B0 all the way to this view here, where we wanted to evaluate it. And so B0, when we try to evaluate this formula, it doesn't know what the value of B0 is at the time, right? If we give it to our Rust formula evaluator, it just, so it will try to calculate 42 plus B0, which doesn't mean anything in this case. And so that's why we, return this kind of value string from the formula engine. So how can we fix this, right? So ideally, what the system should recognize is that B0 instead is another kind of reference that really points to 1, right? And it should really put 1 here instead of another reference, instead of B0. And if it would do that, then it would be able to calculate the final value of 42 plus 1. And so we can actually fix this. We can actually fix this very easily with recursion, right? So instead of what we did here, when we looked up the values, those mentioned values from spreadsheet data, now what we're going to do is we're going to just look up these values from our final view, spreadsheet view, right? Because that one has the final values in it, and that's how we can find out what B0 really points to. And this is kind of like strange, right? If you're not familiar with recursion, because we're actually looking up a value from a view we haven't really declared yet. In fact, we're using this mentions with values view to declare or to build our spreadsheet view. And we're referencing spreadsheet view, on the other hand, it mentions with values. So how does it work, right? And the reason it works is because this is supported by using a recursive query in SQL in our case. So let's try to do that. Let's try to fix our example. So there's 2 things we need to do. So first, we need to fix our mentions with values view. Instead of looking up from spreadsheet data, we'll look up from spreadsheet view. And instead of taking the raw value, right, that the user entered, we're going to take the computed value that we computed from spreadsheet view. So going back to our example, shut it down. I'm going to go into my view here. And we see we're going to change this view here from spreadsheet data to spreadsheet view. And we're going to change, instead of raw value, we're going to take the computed value as the mentioned value. Now, the system gives us some error messages, which are probably interesting to go through as well. So the first thing it says, it doesn't know spreadsheet view, right? And that's the kind of the problem I mentioned, because we're using a recursion now. We haven't actually built spreadsheet view yet, right? Spreadsheet view is built somewhere down here, and it actually depends on this mentions with values view itself. And so to fix this problem, we need to add a forward declaration to it. So we need to declare to the system that, yeah, we have this view, but we'll tell you later about it. But here's the minimal information of what you need to know, right? So which is just what the view returns. And so if we add this forward declaration, we can do recursive, we can use this view recursively. So then it does two other things, which is it wants really these two views instead of having them materialized. Materialized views are just views that we can write ad hoc queries to, and we can like inspect the changes at runtime to it. It wants us to make those views local now. That's just because they're used as part of a recursive computation, so we can't easily expose those values anymore to you. But once we make those views local, the program will compile. And if we compile it and we run this, we should be able to hopefully get the correct output from our system. Take a second here. And we're going to enable, we're going to look at the spreadsheet view again. And so if I start this and we look at it, we see that we indeed now compute the correct value here, which is 42, by adding 41 plus 1, and by indirectly following the B0 all the way to its raw value 1 here, using our recursive spreadsheet SQL. So finally, let's do this. Let's do the example again that we did in the beginning, where we actually go and we change a value, right? Because we also kind of want to know that it only does the minimum amount of updates, right? So if I change this this cell here to a new value, really I only want to see updates for this row here and for the last row because it references this row here. So does it actually live up to its expectations? So we're gonna override again this value 41 to 99. And if I insert that into our system, we see that we did two changes now instead of earlier where we only did one, right? So we actually deleted this row 41 from our spreadsheet view. And we deleted also the second row, which referenced the 41 value, which is the last row here, number 3. And we inserted two new rows into our spreadsheet for ID 0, which has now a new value of 99. And for ID 3, which now has a new computed value of 100, right? So that's the power of incremental computation, right? So even though you might have, a billion cells, the system will kind of automatically figure out for you what are the minimum amount of updates I need to do in order to compute the state based on what I change in the system, right? Based on what query I enter, what kind of insert I do. And this works for any SQL. Here is a spreadsheet as an example, but if you have a complex SQL in your use cases, it will work for those as well, and it will be as computationally efficient as possible in doing these things. Okay, so we have about 4 minutes left. This is probably a good time to stop, and that's also all I kind of wanted to show as part of our webinar. So I'm going to go to my last slide here. And so there's a few resources if you're interested more in this. So the first one is a live demo that I showed you in the very beginning of the spreadsheet, where we use essentially the same code that I showed you here today to run this, to power this thing. And you can play with it and check it out. And then, there's also a kind of a series of articles that shows how to build this yourself. And as a use case, if you have something where you want to build a real-time application, you can follow these guides and build the same kind of system very easily. And we have also the complete code for this. We made it publicly available, so you can check out. This is the code essentially that powers the live demo here, and that is accompanying the article series. All right, that's it. So we have a few more minutes for questions, if there's any questions that you want to ask. Also, I think I wanted to give you a little link of a form. So this is the first time we are doing this seminar series. So, we're very happy for any feedback you can give us. We're also happy to hear from you, especially what kind of content you're interested in the future for this series of webinars. And just let us know if you if you'd like to hear about any topics you haven't heard today, that would be great. Thank you very much. So with that, I'll stop here. Let me know if there are questions I can answer.
Thank you, Garrett. Anybody have any questions?
You can also write in the chat if you don't want to ask. It's perfectly fine.
Oh, our forum is password protected.
Oh, okay. I'll try to fix that. That's strange. That used to work. We'll send it out in an email. Sorry about that. And we'll fix the form link.
There's one question in the chat. How many copies of the original dataset values are kept? For example, one of the intermediate tables had a copy of the value from the spreadsheet. Of the value from the spreadsheet. Yeah.
That's a great question. So the answer is, it's a bit tricky. We would have to look exactly at the query plan to tell you. But essentially, every time you're doing a join, it will copy and keep a copy of the value. And we're doing a few joins here. So that's something that can be done more efficiently. It's something we're actually very much interested in doing more efficiently in the future. So there's a few kind of avenues where we can reduce this amount of copying, and we have plans to improve that. So yeah, and this will not just affect the spreadsheet. Obviously, it will affect any kind of SQL program where you have a bunch of joins that need to store intermediate values. I hope this answers the question.
Okay. Any other questions for Garrett? I think that is, oh. Will this support cycles in Excel? It's a question.
Support cycles in Excel. So cycles, so there is a yes. The answer is yes. I haven't shown this exactly. There is a one line, if you want to so what he's asking really is, in Excel, you can build this kind of computations where, one cell references the other cell, and then it will do a fixed point iteration on those cells to compute some value. And so that actually we can do the same thing. So once you have the recursion, you can do that too. Right now, if you will try to do this in this particular code example that I gave you, it will just it will never start kind of a fixed point iteration because the formula engine will not put as the default value, will not put the number as the default value. So that's why it doesn't start. And then the second problem you will have to solve is you will need to, even in Excel or in Google Sheets, what they usually do is they have an upper limit of how many iterations they will do on your computation. So I think the default on Google Sheets is something like 100. So you would have to put the same thing in this recursion here. So you would have to essentially bound the computation, bound the amount of iterations you want to do. So that's not something we did here in this code, so you would have to add it. But since you have the recursive mechanism in here, it will actually, once you do this, there's a one-line change you need to do in the Rust code to put the initial default value as a number. And once you do that, it will just compute unboundedly in this case. So you'd have to just bound the computation. Okay, so the next question is, what is happening when the pipeline is stopped, changed, and restarted? Is all the data reloaded basically from scratch? So there are several ways. In this kind of example here that I show you, we reload the data from scratch is very trivial because we just had a data gen thing that inserted 4 rows. In general, in Feldera, there's several mechanisms to avoid this reloading. So we have a checkpointing mechanism where the pipeline is occasionally checkpointed, and then you can kind of, instead of restarting from scratch, you just restart from the latest checkpoint. So this is also how we implement our fault and pipeline mechanisms.
All right. Another question.
This support external API calls in the UDF. Yeah, so let me show you. So you mean when you say external API calls, you mean like using something to, so there's two things, right? External API calls can be, you invoke a library, which is what we just seen here in our UDF.rs function. So we actually import those libraries, Chrono and Excel Formula Engine, which we declare using our UDF TOML file, and that's perfectly fine. And then I think your question is more about, could this make like a network call to some API host and get some data and run that? And the answer is yes. So there's no restriction in what UDF code you write, right? So you can totally do a network call. The only kind of problem that you could run into it, right, is like if your latency of your computation is bounded probably by this network call. So if this is going to take a long time, the performance of your pipeline might suffer. There's ways in how we're thinking and how we could optimize this, right? So some of these things could be just async functions, and we could make our pipelines more asynchronous to kind of support this model better if that's important. But, we currently don't have any plans or any immediate plans to do that. But it's definitely, there's definitely ways you could do it. But even now you can do it. If you're not like too worried about performance, you can totally call any kind of API you want. Thank you very much. And